ಗುಡ್ ಆಫ್ಟರ್ನೂನ್ ಸ್ಟೂಡೆಂಟ್ಸ್. ಎಲ್ಲರಿಗೂ ರಾಜೇಶ್ವರಿ ಫಿಸಿಕ್ಸ್ ಕ್ಲಾಸಸ್ ಯೂಟ್ಯೂಬ್ ಚಾನಲ್ಗೆ ಮತ್ತೊಮ್ಮೆ ಸ್ವಾಗತ. ಇನ್ ಟುಡೇಸ್ ಕ್ಲಾಸ್ ವಿ ಆರ್ ಡಿಸ್ಕಸಿಂಗ್ ಅಬೌಟ್ ದಿ ಸೆಕೆಂಡ್ PUC ಫಿಸಿಕ್ಸ್ ಪಾರ್ಟ್ 1 ನಲ್ಲಿ ಬರ್ತಕ್ಕಂತಹ ಒನ್ ಆಫ್ ದಿ ಮೋಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಆ್ಯಂಡ್ ಈಸಿಯೆಸ್ಟ್ ಡಿರೈವೇಷನ್, that is applications of the Gauss law. One of the most applications of the Gauss law, that is a electric field due to a uniformly ಚಾರ್ಜ್ಡ್ ಇನ್ಫೈನೈಟ್ ಲಾಂಗ್ ಸ್ಟೇಟ್ ಕಂಡಕ್ಟರ್. ಅಂದರೆ ಈ ಒಂದು ಲಾಂಗ್ ಸ್ಟೇಟ್ ಕಂಡಕ್ಟರ್ ಐತೆ ಅಂತಂದರೆ ಇದೊಂದು ಪಾಯಿಂಟ್ ಕನ್ಸಿಡರ್ ಮಾಡಿತ್ತು ಅಂದರೆ ಈ ಪಾಯಿಂಟ್ ಒಳಗಡೆ ನಮ್ಮದು ಇಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಎಷ್ಟು ಬರ್ತೈತಿ ಅನ್ನೋದು ಇವತ್ತು ಏನು ಮಾಡೋಣ, ನಾವು ಡಿರೈವ್ ಮಾಡೋಣ. ಈ ಡಿರೈವ್ ಮಾಡಬೇಕಂದ್ರೆ ನಾವು ಏನು ಮಾಡಬೇಕು ಸ್ಟೂಡೆಂಟ್ಸ್, ಇಲ್ಲೇ ಸ್ವಲ್ಪ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೋಬೇಕು. ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ದಿಸ್ ಇಸ್ ಅ ಲಾಂಗ್ ಸ್ಟೇಟ್ ಕಂಡಕ್ಟರ್. ಅಗೇನ್ ಬಿಕಾಸ್ ಆಫ್ ದಿಸ್ ಲಾಂಗ್ ಸ್ಟೇಟ್ ಕಂಡಕ್ಟರ್ ದ ಲೆಂತ್ ಆಫ್ ದಿ ಕಂಡಕ್ಟರ್ ಎಷ್ಟೈತೆ ನನಗಿಲ್ಲೇ ಎಲ್ ಅಂತ ಕೊಟ್ಟಿದ್ದಾನೆ. ಅಗೇನ್ ಇಫ್ ದಿಸ್ ಲಾಂಗ್ ಸ್ಟೇಟ್ ಕಂಡಕ್ಟರ್, ಸಪೋಸ್ ಇದು ಒಂದು ಲಾಂಗ್ ಸ್ಟೇಟ್ ಕಂಡಕ್ಟರ್ ಐತೆ ಅಂತ ತಿಳ್ಕೊರಿ. ಈ ಪೆನ್ ಏನ್ರ ಲಾಂಗ್ ಸ್ಟೇಟ್ ಕಂಡಕ್ಟರ್ ಇತ್ತು ಅಂದ್ರೆ ಇದರಿಂದ ನನಗೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಡ್ಯೂ ಟು ಎ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇದ್ರೆ, ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಅಂತಂದ್ರೆ ನನಗೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಹೆಂಗೆ ಬರ್ಬೇಕು, ನನಗೆ ರೇಡಿಯಲಿ ಔಟ್ವರ್ಡ್. ಇಫ್ ದಿ radially outward in all the points of a conductor, then at certain distance this shape of a electric field is assumed as a cylindrical shape. Then that shape is called as Gaussian surface. So ಇದಕ್ಕೆ ಅಂತ ಕರಿತೀನಿ ನಾನು Gaussian sphere ಅಂತ ಕರಿತೀನಿ. The surface within the Gaussian sphere is called as Gaussian cylinder is called as Gaussian surface. Okay, in that consider L be the length of a conductor and lambda be the linear charge density. That is nothing but a lambda is equal to the Q divided by L. This is known as linear charge density. Because of this positive charge, the electric field lines are radially outward, that is perpendicular to the surface of a cylinder. Now let us consider ಈ ಒಂದು ಡೈಗ್ರಾಮ್ ಒಳಗಡೆ ನೋಡ್ರಿ ಸ್ಟೂಡೆಂಟ್ಸ್, ನಾವೊಂದು ಇಕ್ವೇಷನ್ ಡಿರೈವ್ ಮಾಡಬೇಕಂದ್ರೆ ಈ ಡೈಗ್ರಾಮು ಭಾಳ ಒಂದು ಇಂಪಾರ್ಟೆಂಟ್ ಆ್ಯಕ್ಟ್ ಆಕೈತಿ. ಯಾಕಂದ್ರೆ ನೋಡ್ರಿ ಇದ್ರೊಳಗಡೆ ಎಷ್ಟು ರೀಸನ್ಸ್ ಅದ ನನಗೆ. ಈ ಒಂದು ಟಾಪಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ಸರ್ಕುಲರ್ ಎಂಡು, ಅಗೇನ್ ಕೆಳಗಿರ್ತಕ್ಕಂಥ ಒಂದು ಸರ್ಕುಲರ್ ಎಂಡು, ಅಗೇನ್ ಕರ್ವ್ಡ್ ಸರ್ಫೇಸ್ ಒಂದು. ದೀಸ್ ಆರ್ ದ 3 ರೀಸನ್ಸ್ ವಿಚ್ ಆರ್ ಪ್ಲೇಸ್ ಅ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ರೋಲ್ ಇನ್ ಫೈಂಡಿಂಗ್ ದಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಟ್ ಅ ಇನ್ಫೈನೈಟ್ ಲಾಂಗ್ ಸ್ಟೇಟ್ ಕಂಡಕ್ಟರ್. ಅಗೇನ್ ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ಹಿಯರ್ what are the electric flux flows through a reason 1, that is phi 1 is equal to ಯಾವ ರೀತಿ ಬರೀಬಹುದು ನಾನು, E into A into cos theta. Then what is the angle between the, where theta is called as the angle between the area vector to the direction of the electric field. In reason 1 this theta is equal to 90 degree. If theta is equal to 90 degree, then what happens to the cos theta? Cos theta is equal to cos 90, then cos 90 is equal to 0. If the cos 90 is equal to 0, then phi 1 is equal to E into cos of 90 is equal to 0. Then 0 into anything is equal to 0. Then similarly find the electric field at reason 2, that is phi 2, that is EA cos theta. Here in reason 2, see students, the area vector and the direction of the electric field are along the same direction. Then in this case theta is equal to 0 degree. Similarly, if we substitute the theta is equal to 0 degree, then cos 0 is equal to 1. Then phi 2 is equal to E into A into cos of 0, that is E into A into 1, that is maximum, that is phi 2 is equal to E into A. Where A indicates A ಅಂದರೆ ಏನು ಸ್ಟೂಡೆಂಟ್ಸ್, ಇಲ್ಲಿ ನಮಗೆ ಏರಿಯಾ ಆಫ್ ಎ reason, that is reason 2. This reason 2 is in the form of curved surface. Then the area of a curved surface in the reason 2 can be written as 2 pi RL. While substituting this A in this phi 2 equation, then we may get phi 2 is equal to E into 2 pi RL, where phi 2 is equal to E into 2 pi RL. This is the electric flux passes through a reason, second reason. Similarly, we find the electric field due to a third reason. In third reason, that is phi 3 is equal to E into A into cos of theta, where in this case theta, let us see students, the reason 3, where reason 3, here the theta, the angle between the area vector, that is perpendicular line drawn to a surface to the direction of the electric field, is taken as a 90 degree. If we substitute in the equation theta is equal to 90 degree, then cos of 90 is equal to 0. If cos of 90 is equal to 0, then phi 3 is also become a 0. Then in order to get the total electric flux flows through a Gaussian surface is equal to total electric flux flows through a Gaussian surface can be written as phi is equal to phi 1 plus phi 2 plus phi 3. Then we substitute the value of phi 1, phi 2, phi 3 in this equation. Phi 1 is equal to 0 plus phi 2 is equal to 2 pi RL into E plus phi 3 is equal to 0. Then the total electric flux flows through a Gaussian surface is equal to 2 pi RL into E. This is equation number 1. Similarly, we have already know the idea about the Gauss law. Then according to the Gauss law, same, the electric flux flows through a Gaussian surface, that is closed surface, can be written as Q divided by epsilon naught. This is equation number 2. While observing the equation 1 and 2, both are telling the same thing about the electric flux. Then we can easily equate equation 1 is equal to equation 2. While equating the equation 1 and 2, we get 2 pi RL into E is equal to Q divided by epsilon naught. As our aim is there to determine the value of the electric field, in order to find the value of the electric field, then we send them other side to the 2 pi RL to the other side. Then we get E is equal to Q divided by 2 pi RL epsilon naught, where we have idea about the linear charge density, that is lambda is equal to Q divided by L. Here we observing that value of Q by L. While replacing the Q by L in this equation by lambda, again we get E is equal to lambda divided by 2 pi R epsilon naught. See students, this is the expression of the electric field due to a uniformly charged long straight conductor. Thank you.